In this video, we're going to talk about how to solve rational equations. To solve rational equations containing rational expressions, we're going to follow these 4 steps. The first step is to multiply both sides of the equation by the lowest common denominator of all rational expressions in the equation. So we'll need to check out every denominator, make sure it's completely factored, and then build our LCD upon those unique factors. In step 2, we'll simplify both sides of the equation. In step 3, we'll determine whether the equation is linear, or quadratic, or higher degree, and solve accordingly. So if it is quadratic, we might need to use factoring to help us to solve. In step 4, we're going to check our solutions in the original equation because there may be restricted values. In example 1, we have 2 divided by x minus 5 plus 1 divided by 2x equals 5 divided by 3x squared minus 15x. So in order to solve this rational equation, we are going to look at our denominators and make sure they are factored. X minus 5 is a quantity, and that is completely factored. 2x means 2 times x, that is completely factored. 3x squared minus 15x, I notice that although there are 2 terms, I have a greatest common factor because 3 and 15 are both divisible by 3, and both terms also involve x. So 3x would be my greatest common factor, leaving x minus 5. So to build our lowest common denominator, I'm going to start back in the first denominator. The quantity of x minus 5 is needed. That is a unique factor. Remember, 2x comes from 2 multiplied by x, so I need 2 multiplied by x. And then in my last denominator, I have 3x. That's 3 times x. So 3 is another unique factor that needs to be included, but x minus 5 is a quantity that we already have. So I would multiply 2 times x times 3. That makes 6x times the quantity of x minus 5. So we have our lowest common denominator. To find any restrictions on the variable, we set each factor equal to 0. So we would have to take 6x, set that to 0, and x minus 5 set to 0. So I know that if x is 0, I'm going to have 6 times 0 equals 0. So x cannot equal 0. And for the other factor, x minus 5 set to 0, adding 5 to both sides would mean x equal to 5 would cause the denominator to be equal to 0. So both 0 and 5 need to be eliminated from possible solutions. Our domain is the set of x such that x is a real number. X cannot equal 0 or 5. So now that we know the domain, we can go ahead and solve the problem, and if any of our solutions are either 0 or 5, those would need to be eliminated. We're going to use our lowest common denominator now to multiply each term in the equation. So I'm starting with 6x times the quantity of x minus 5 multiplied by our first fraction, 2 over x minus 5, added to our lowest common denominator, which is multiplied by our next term, and that is equal to the lowest common denominator multiplied by our final term. Now it is important that you keep this final term in its factored form, and that will just make it easier for you to see what reduces. So I'm writing the factored form there. Now what is going to happen here is you'll see that you should be able to do some reducing. The quantity of x minus 5 in this first term is reduced, and now we don't have a fraction remaining. That was the whole purpose of multiplying by the lowest common denominator. In our second term, we can see that x reduces with x, and 6 dividing by 2 would leave 3. So again, no fraction remains. And in our last term, the quantity of x minus 5 reduces, x reduces with x, and this time 6 reduces with 3, leaving us 2 in the numerator. So what we have remaining is 6x multiplied by 2, which would be 12x. Positive 3 is distributed to each term in our quantity and then multiplied by 1. So multiplication of 1 is not going to change our products. So it's essentially like distributing 3 times x and 3 times negative 5. So that would give us positive 3x minus 15. Our final term is 2 multiplied by 5. So we have this equation now equal to 10. Scanning the problem, I don't see any second degree terms, so we should end up with something linear to solve. 12x plus 3x are like terms, and that gives us 15x minus 15 is equal to 10. So I want to add 15 to both sides of the equation to get my variable term isolated. 15x is now equal to 10 plus 15, which would be 25. And to solve for x, I'm dividing each side of the equation by 15. So it looks like I can reduce 25 fifteenths. Each is divisible by 5, and that would leave me 5/3 for the value of x. So I want to make sure I go back and check the restrictions. It says x cannot equal 0, x cannot equal 5. I didn't get either of those answers, so it means we get to keep our answer of x equals 5/3. So we have one solution. In example 2, we have 1 over x minus 4 minus 3x over x squared minus 16 equals 2 divided by x plus 4. So let's make sure all of our denominators are factored. So it looks like x minus 4 is okay, but x squared minus 16 is a difference of squares. So I know that will factor as quantity x plus 4 times quantity of x minus 4. Our last denominator is x plus 4, so that's factored. To build our lowest common denominator, we're starting with our first denominator, quantity x minus 4. Since that's a unique factor, we need all of it. In our second term, quantity of x plus 4 is unique, so we also need to multiply by quantity x plus 4. Quantity of x minus 4 is already included in our LCD, and our last denominator of x plus 4 is already included. Checking out the powers. It looks like everything is raised to power of 1, so our lowest common denominator is the quantity of x minus 4 multiplied by the quantity of x plus 4. So to find the restrictions, that means we're setting each factor equal to 0. So x minus 4 set to 0 means that the x value of 4 would make this equation equal to 0. For the second factor, x plus 4 set to 0, subtracting 4 means an x value of negative 4 would make that 0. So our domain is the set of x such that x is a real number, but x cannot equal 4 or negative 4. To go about solving the equation, we're going to multiply all terms by the lowest common denominator. So our first term is multiplied by the LCD. Now we have subtraction in this equation, and it's always a good idea to follow subtraction with a bracket, because anything that is remaining in this bracket will have to have this negative distributed. So I start with my lowest common denominator and multiply by the middle term. Again, I'm going to keep my denominator in its factored form, and it's all in the bracket. And that would equal my lowest common denominator multiplied by the last term. So what should happen is a lot of reducing, and all of our fractions should eliminate. Our quantity of x minus 4 reduces in the first term. Inside the bracket, both of these quantities are actually reducing. And in the last, quantity x plus 4 is reduced. So you can see we have no fractions remaining. 1 is being distributed for the first term. That just leaves us x plus 4. Now work inside of the bracket first. It looks like all we have is 3x. So the negative is multiplied by 3x. That would be minus 3x. Last 2 is distributed to each term in this quantity. That would give us 2x minus 8. Scanning, I don't see any second degree terms, so again we have something linear that is remaining. To collect our like terms, minus 2x plus 4 is equal to 2x minus 8. So I want to collect all my variables on the left. That means I'll subtract 2x from each side. And that leaves me negative 4x plus 4 equals negative 8. Subtracting 4 from each side, that will leave me negative 4x equals negative 12. So I'll divide each side now by a negative 4 to solve for x. Negative 12 divided by negative 4 would make positive 3. Checking out our restrictions. Positive 4 and negative 4 are the restricted values. We don't have either of those values, so we get to keep our one solution, x equals 3. In example 3, we have x minus 3 divided by 2 minus 1 over x minus 3 is equal to 8 minus 3x divided by x minus 3. Looking at all denominators, it looks like everything is already factored this time. So we'll build our lowest common denominator with the product of each unique factor. So 2 is a unique factor. Quantity of x minus 3, notice, is identical in the other denominators. So I just need to write that one time because it's written as a power of 1 in each individual denominator. Restrictions. Setting 2 equal to 0 doesn't generate a restriction because there's no variable there. And then setting x minus 3 equal to 0 would mean x equals 3, so we must eliminate x equals 3. The domain is the set of x such that x is a real number and x cannot equal 3. So we're taking our lowest common denominator now and multiplying every term in the equation by it. So that would be quantity of x minus 3 over 2. With subtraction again, I'm using my bracket, starting with my lowest common denominator, multiplying by the next term, close the bracket. Start again with the lowest common denominator, multiplying by our last term, and now I'll reduce. 2 reduces with 2, so we have no fraction remaining. In the second term, quantity of x minus 3 is reduced. And last, again, that quantity of x minus 3 is reduced. So notice we've got 2 binomials remaining. So we're going to have to distribute x times x times negative 3 would be x squared minus 3x. Now distribute this negative 3 to each term. So a minus 3x plus 9. Inside of the quantity, I have 2 multiplied by 1 gives me 2, but distribute the negative. So I actually am subtracting 2. On the right side of the equation, 2 will be distributed to 8 and negative 3x. So 2 times 8 would give me 16. 2 times negative 3x would be minus 6x. Let's collect all of our like terms now. It looks like we do have a second degree term. So factoring will need to be used to solve this. I have 2 first degree terms, so it's minus 6x. Positive 9 and negative 2 would give me positive 7 equals 16 minus 6x. So since it is quadratic, I want to collect all terms on one side and set it equal to 0. So I'll take away 16 from both sides, and I'll add 6x to both sides. Now let's see what happens here. 16 minus 16 is eliminated. Minus 6x plus 6x, so I know that I have something equal to 0. X squared. Negative 6x, add 6x is eliminated. Negative 9. So it looks like I have x squared minus 9 is equal to 0. Do you recognize that that's really a difference of squares? So the factoring that's needed is quantity of x plus 3 times quantity x minus 3, and that's what is equal to 0. Now our zero factor property tells us to set each of these equal to 0. Once we solve, we'll get x equals negative 3, and we'll get x equals positive 3. Now be sure to go and check the restrictions. X cannot equal positive 3. So we have to eliminate one of the solutions. So we really only end up with one solution, and that is x equals negative 3.